Welcome back to the Home Lab, and today we're going to do something a little bit different. We're going to have a look at a lovely modern take on a VFD clock. I recently received an email from a viewer who said he'd seen my VFD display project, and he very politely said that he'd got a real passion for VFDs as well, and that he manufactured modern VFD clocks. And he asked me, would I like to feature one? And I said, well, yes, of course I would. So he said, okay, I'll send you a couple to have a look at. So what seemed like a very short time later, there was a knock on my door, and the postman brought me a beautifully packed package with these two safely inside. So let's have a look at what Aidan sent me from LGL Studio. And what I'm going to do too is explain the science and physics behind how these displays work. And they're a lot cleverer and a little bit more complicated than the one I built. So let's have a look at what Aidan sent me, and he very kindly sent me two clocks, and these came packaged together in an outer package, so they were really well protected, and I don't think there's any risk of them being damaged in transit with the usual throwing about of parcels that we've come to expect these days. It's also beautifully sealed with this tape, so you can see no one's been in it since it left his factory or where he makes these things. So let's open it up and have a look at what's inside. And this is really exciting for me because I haven't done this myself so I want to see what's in here. So some instructions, and I presume these are in multiple languages, and we'll have a look at those in a minute. But that actually looks really fantastic. I mean, I like his branding, and I think the idea is these are things that you can give to people as a present. That's an absolutely lovely box. So let's open it up and see what's inside. So I'm already really impressed by the box that's got a really sturdy feel to it, and it's absolutely beautifully made. So it has the total feel of a really quality item, and I know that Aidan is very proud of these, so he's put a lot of effort into the design and packaging. So inside the box, what you'll see is the Perspex panels that we're going to use to put the clock together, and the electronics itself deep inside there, which we'll explain. A USB lead, and that's really interesting because you might know, and I'll explain later, that VFDs use quite a high voltage, but because they're very, very low current, because they don't have a hot heater, you can drive them off low voltages just boosted up, and USB does that beautifully. And of course, when we finish putting it together, we've got some nice soft feet to put on the bottom before we put it for display on our desk. So I've emptied the box, and it's really interesting. I hadn't realised that the clock comes completely made already, and it does look absolutely beautiful. And I don't know whether I was sent these just because I'm doing the video, or whether they come with every clock you buy, but this is a spare set of Perspex parts, so I guess if you were to scratch them you could replace them. And one thing that's really lovely right in the bottom of the box, because I know you'll be obsessive about this, are some wipes for the clock, so you can make sure that the Perspex is shining and really, really clean when you put it on your desk. So what I'd like to do now is actually get this wired up and working, explain a little bit about how the display works and how the electronics inside works, and show you how you can set the clock, and it also has some internet connectivity as well. Now, as you might guess, I'm itching to plug it in, but I should really quickly just show you the instructions. And whilst you can see the Chinese on this side, if you open them up, there's two sheets of A4 paper, and this one has all the English instructions on it. And again, compared with some of the things that you can get on the internet, quality. It's printed on good quality paper with a bit of colour as well, and I can even read that without my glasses on. So let's plug it in and see what happens. So I've uncoiled the USB lead, and talking about quality again, it's a good quality cable, which is very pleasing, and USB-C, which is also good news because you're not going to have to worry about this, which way round does it go, etc. So I haven't wired it up yet. I've plugged the other end into my USB port, so let's see what happens when we plug that in. Oh, lovely. So it's scrolling through the hours and things. It said hello to me. Oh, hello back. So it speaks English, and we've got some nice colourful LEDs in there. So it's certainly working. Clearly it's not the right time. We would have gone back a few days, but it's working beautifully. It's very clear display because it's actually quite bright in here. So let's have a play with the settings and see what this clock can actually do. Oh, whilst we're at it, I thought before I do any settings, etc., I just connect it up to a little USB power meter and see what sort of current it draws. So it's drawing about 0.37 amps, which is not too bad at all. The voltage is slightly below 5, but that's because I've got an extension USB lead as well as the white one here. So just before I connect it up to the Wi-Fi and show you what settings we can do there, including getting the time set on it correctly, I just want to show you the back of the device because there are two little switches here, switch 1 and switch 2, and the instructions are an absolute joy. They're in really clear English and really easy to follow. So if we look at switch 1, which is this one, if we press and hold it, what happens is the lighting goes out. So perhaps if you want to sleep and you don't want them flashing, press and hold again, and back on they come. And then you can scroll through different coloured settings. So there's plenty to play with. I'm not going to go through all of them now, but if you're one of those people who likes to set different moods with their little clock, that's what that switch is for. And then when you go to sleep, just press and hold it, and out they go. Now, as I showed you on the back, there's another switch here, S2, and that one allows you to do a number of things, but one of the things is, and we talked about going to sleep with a clock like this by your bedside, if you press it once, what it does is it sets the auto brightness, so you can get different brightness levels. I don't know how well it comes out on the camera, but it's getting dimmer and dimmer now. There's an auto level, and then there's the really bright level that I had it set on to begin with. But this switch also does something else if you double click it. So, as I said, if you double click S2, that's the outside switch, you change the scrolling of the display. So currently we're on display 0 and it shows the time fixed. I've double clicked it to display 1 and we see the time, and if you wait a few seconds, it's about 5 seconds, it goes to the date, and wait about another 5 seconds and it goes back to the time. So that's display 1. So I'm going to double click again to display 0 and that shows the time fixed on the display. Now, going back to S1 quickly, just before we finish clicking on the switches, and it's very, very intuitive, which is fantastic. I've actually got one from a different company on my desk, and I still haven't really worked out how to set it, so this is a joy. If you press S1, that's the inner of the two switches, it tells you which LED mode you're on. I don't know if you saw it there, LED 14, LED 15, LED 16, and they're currently off, but of course if you press and hold, they come on and you can see what pattern you've got. So I'll do another click and you can scroll through all the different patterns that there are, and if there's one you want to actually remember, then when you click it, if you remember, you very briefly see there was LED 20, which one you've chosen. So I thought it might be interesting for me to show you the circuit board in here, how it's put together and what the components are. So I hope Aidan and his team at LGL Studio don't mind, but I'm going to take a spanner to it and I'm going to undo the case, and we're going to have a look inside at the circuit board, how the components are mounted and what each one does. And I think you'll be impressed just by how well this device is put together. So we'll turn the power off and we'll unplug the USB-C connector, and I'm pleased to see that the actual connector on the circuit board is well mounted, so that's good news, because it's really annoying when those begin to break off as you plug and unplug things. So I guess this will just sit on your desk and you won't be constantly plugging it and unplugging it. So we'll undo these little cap nuts here and they're quite nice because they cover up the threads really well and sort of match the colour scheme of the whole clock. And I really like this kind of construction. I've built quite a few projects out of stacked perspex and spacers, and it works really well. And it also has the advantage that when you take off the perspex sheets, you can then clean them. You've got to be careful not to scratch them, but it means you can get the dust out and things like that. So let's take the other layers off and have a good look at the circuit board. Now, I often use screwed together little spacers, but this is going to be really easy because it just lifts off and it takes its spacers with it. And I'm not going to forget how to put it back together again, but I'm going to lay it out on my bench out of the way so I don't make a mistake when I end up putting the whole thing together. But that's rather nice. If you had to clean it, it's really very quick to take apart, and we'll get down to the circuit board in a moment. So there we go, I've removed the last perspex sheet that I need to, and you can see the VFD, the display part there. And if I just turn it around, there's a couple of spacers here to make the perspex sheet clear the circuit board. And you can see the circuit board with its components on, and we'll go through each of those. And Aidan tells me that this is all their own design, and even the circuit board is a bespoke design by them, and they have it purposefully made for their clocks. So let's have a closer look at what's going on inside with the electronic circuit. So now I've got it apart, let's have a quick look at the circuit board and how it's all put together. But firstly, I've got to tip it forward slightly because you get a really good view of the back of the anodes there, where the display is. And on the other side of those is where the fluorescent material is mounted that glows when you actually see the time. So I'll tip it back. I'm going to be really gentle, little loose bits there. And I'll move the camera slightly and we'll have a look at the circuit board directly. Right, so we got a good look at the circuit board now, and it's really nicely presented. And what I like about it is because the components are very small and the board is quite large, because the clock's reasonably large, is there's plenty of space on the board to see what's going on. So here's the USB port coming in, and as I said to you, I think that's really well supported on the board, so it's probably not going to lift or break off, which is really annoying when that happens. And then if we go over to this side, we've got the power that's come in going into a boost converter. You can see the capacitor there. And the boost converter, if you've ever played with those, takes a DC voltage and boosts it up. So we've got 5 volts here going to about 28, which will drive the anodes on the vacuum fluorescent display. Then if we move across, you'll see this large chip here. And this is another surface mounted device. Everything on here is surface mounted. And this is the eTech 16315. I think it's a 44 pin chip. And this is the display driver and controller. So we can control what we see on the display by using this chip. Then if we move across, we've got some more components here, and we need to do some more things with the power that we're getting. So we've got a little series of components here, which is an LDO. It's a low dropout regulator. At least I think I've got it right. And that feeds 3 volts into the chips that here, certainly the Wi-Fi chip that we'll look at in a second. And LDOs are really useful little things because they can actually work to drop the voltage even when the input voltage is very, very close to the output voltage that's required. There's no switching at all, so you don't get any switching noise, but they do dissipate just a little bit of heat, but that doesn't matter too much in this environment, especially with an open case. It's not really going to get warm. So here's the real-time clock chip. And this is quite a clever little device. This is the R8025. It's a high precision, very low power real-time clock chip. And it's got a digitally controlled oscillator that's 32.768 kilohertz. And if you recognise that mathematically, that's 2 to the power 15. And you can divide that down to get the clock pulse rate that you need. And then we move along here, the antenna being the giveaway, to the ESP-M module. That's the Wi-Fi module, and you can see its little antenna there. So there's one other component here. I think that's a buzzer, which the clocks have on them, but I haven't really investigated that. But it's nicely laid out, all surface mounted, And of course, the bits you can hardly see down here are the little LEDs that light up and give you all those wonderful colours when you switch on the clock. Well, that was easy. So with the clock clean and all put back together again, I'll plug it in. There we go. And all that remains for me to do now is to get it working on Wi-Fi and to explain how the VFD display works. I must say I was a little bit nervous about how easy it would be to connect it up to the Wi-Fi in the house to make sure that it gets network time, because you can't set the time directly on the clock. You have to be connected to Wi-Fi for it to find network time. And in fact, it turned out much easier than I thought it was going to be. You know, you can have nightmares with these sort of things, but in fact, it was really easy. You just go to your device. I went onto my desktop. Go to your Wi-Fi settings, find the Wi-Fi for the clock, and I found that very quickly. Select that, and as soon as you do that, your computer or device sees the Wi-Fi from the clock. It brings up a little table where you fill in the settings that you need for your home Wi-Fi. And then with that done, you switch back to your home Wi-Fi. There's a setting on here which allows you to see the IP address of the clock. And once you've got the IP address of the clock, you can put that into your browser, and then up comes a setting page, and that setting page has everything you need to change the settings on the clock. So I'm reasonably tech savvy, but quite often these things aren't very easy, but it turned out to be really, really easy. And in fact, I found a very good walkthrough on how to do it with this clock on Google, and I'll put that in right at the end of the video. So let's now explain how the VFD display works. And there are two types typically that you'll see about. There's the old-fashioned type, like the video number display that I did, that uses deep and thick glass tubes. And then there's the really thin display, like the one on this LGL Studio clock. So I made a little demonstration here to show you how the tube is made up, and it's the same for both types. So if I fold back some layers here, you'll see that at the back of the tube there are the segments that actually glow, and they're made of a metal, usually put on a glass substrate, which is very, very see-through, and the metal itself I think is aluminium. Then on top of that is a phosphor coat, and that's the bit that's going to glow. And to each segment there's a wire or connection that leads away to the control circuitry. Now you'll notice here what's really fun about these things is you can't change the display once you've made it. Obviously you can switch on different segments, but you can have any shape you like. And you can also have any colour you like, depending on the phosphors that you put on. And there's a whole range of phosphors, but typically they're a sort of cyany blue, and orange and sort of yellowy colours are quite popular. So those are the anodes. Then on top of that, if I can separate these two layers, they're sort of stuck together, is a whole series of wires going in an XY direction, a sort of grid. Now it can be a sort of honeycomb shape, but I've drawn it as a sort of chessboard shaped grid here. So these are very, very fine wires in a grid, and in fact they're so fine you don't really see them. And if you know anything about triode valves, this whole system behaves in a very similar way. And then in front of that, and the bit that's really difficult to see, are very, very thin wires that typically go across the display, and that's the cathode. So now you know how all the bits are put together in the tube, let's explain what voltages are on them and how each one works. So I showed you the cathode wires that run across, and they're a bit like the filament wires in a normal thermionic valve. But here's the clever bit. They're made of tungsten, but they're coated with a metal oxide that has a very, very low work function, which means that it doesn't need to get very hot or have a very high potential on it for electrons to boil off its surface. And that's really clever, because VFD displays, if you feel them, get slightly warm, but they're actually quite low power because these filaments don't glow bright red or even brighter than that like they do in a thermionic valve. So in a thermionic valve, they're about 2,200 degrees C. But in a VFD, they're turned up only to about 650 degrees C. So you don't see them glowing, so they don't get in the way. But what does happen, of course, is billions of tiny electrons boil off these filaments and will remain around the filament as a sort of space charge, they're negative, unless you drag them away. So what you do is you drag them away with a positive grid, and that's the grid we showed in front, and you can change the voltage on that grid. So if you change the voltage, if you make it more positive, you'll drag the electrons through faster. In other words, you'll accelerate them more correctly, and they'll hit the phosphor on the back and make it really bright. If you turn down the voltage or make it should we say 0 or negative, for example, electrons won't be accelerated through the grid, so the segments will turn off. Now, the next thing we need to do is make sure that we attract electrons to each different segment. So you can see the segment wires here. We've got the metal back piece with the phosphor on it, and if we make that positive in the region of about 25 to 28 volts, so a low voltage device for a device that behaves like a thermionic valve, the electrons will be attracted to the positive segments, and as the electrons hit the phosphor will absorb that kinetic energy and will release it as photons of light. So it's really a very simple device. A warm but not glowing hot cathode with a very low voltage on it, 3 to 5 volts, an accelerating grid, and then positive anodes covered in a phosphor coating that will release photons when the electrons crash into it. Finally, how do we actually get different segments to light up? Well, there's two ways. The one I've drawn here, which is like the LGL Studio clock, each anode has an individual connection to it, and therefore if we make an anode positive, that one will attract electrons and glow, and if we don't, it will be switched off. There is another way where you put a grid in front of each segment and you actually control the grids very rapidly, and that's a sort of dynamic system, whereas this one uses a static system where the grid could be on all the time, but we're switching different anode segments on and off. So let's have a chat about why VFD displays are so good at what they do and why they're still around. So in the early days of bright displays, when the LED came out, you might have seen them on calculators and things like that. The displays were quite limited to what they could do, and also they were quite high power devices. Whereas the VFD display is a remarkably low powered device, in fact, for the brightness that you get. And obviously they don't have as lower power as liquid crystal displays, but what you gain is this fantastic brightness that you don't get with a liquid crystal display that has to be backlit from behind. The other thing that I've found that might not affect you, but I've flown aeroplanes with LCD displays in them, and they have a polarizing sheet in front. And if you wear Polaroid glasses when you're flying to block out a bit of the sun's intensity, at certain head angles, the displays, because the Polaroids cross, just go completely black and you can't see them. But of course this brightness is absolutely fantastic, and it's really good obviously for clocks being used at night, but they show up really well in the day too. The other thing that's absolutely fantastic compared particularly with LCD is the viewing angle is so amazing. Think about some of your laptop screens and how well you could see those at different angles. But the viewing angle is absolutely fantastic because they're throwing out photons in sort of all directions, so you don't have to be head on to the device. The other thing that's really good about these is they're not very temperature dependent, so they're used a lot in environments where the temperatures aren't really suitable for other types of displays, particularly the liquid crystal ones. And I've got one of those sort of builder's radios that I use in the garden, and when it's very cold when I'm working outside, I can't read the LCD display on it at all. Whereas these ovens, microwaves, things like that, they work really well even if the temperature changes, and the brightness isn't really affected at all. The final thing about them that I'd like to say is, in fact, you can sort of bang them around a bit and they're really robust. I mean, sure, that it's a glass tube with small little bits of wire in them, but considering how sort of finely they're made, they're actually remarkably robust for the uses that we put them to. So I do hope you enjoyed that look at the lovely vacuum fluorescent display clock from LGL Studio. I'm going to put loads of links below, so if you want to have a good look at what they do and the products that they make, you can learn a little bit more from there. And if you're interested in getting one, there are obviously links to their website where you can purchase them. And I don't make any money from this, but he did give me the clocks for free. But just before we finish, I want to say a huge thank you to Aidan and his team at LGL Studio for very kindly sending me one of these beautiful modern VFD display clocks. I've got a great passion for these things, and he shared his passion for them with me as well. So this is going to take pride of place on my desk by my computer where I do my video editing. And it's a really good reminder of a lovely and old display technology which still has a place in a very modern world.